Hello. Okay, so we are starting off this unit, this other half unit, with function operations and function composition, and they're different, so please make sure you take the time to figure out which is being asked. Now, if you look, addition, subtraction, multiplication, and division, the four operations are listed right here, and you can tell because there's the plus, the minus, the multiplication symbol, and obviously division. You can also write it as f of x plus g of x, okay, or f of x minus g of x, and so forth. Now, notice it also says g of x cannot be 0, so I can't divide anything by 0 because it becomes undefined. Okay, very simple. Know that it can be written in either order. They will always give you f of x and g of x or h of x, depending on what you're being asked to evaluate. And if you look at example number 1, we have f of x defined as 5x cubed plus 1, and then g of x as x squared minus 4. So we're going to find the following. Now for a, it's f plus g of x, which means f of x plus g of x. You're more than welcome to rewrite it if this looks a little bit easier for you. So we're going to take f of x, which is 5x cubed plus 1, and we're going to add it to x squared minus 4. Okay, there's nothing to distribute, so we can drop the parentheses and just continue and combine like terms, so we get 5x cubed plus x squared minus 3, and that is our new added function. Okay, same thing goes for subtraction. We have f of x minus g of x. This is where the parentheses are really going to come in handy because we've got that negative. So f of x is 5x cubed plus 1. I'm just going to substitute that in for f of x minus g of x, x squared minus 4. Okay, so we have a negative, or actually, sorry, not a negative, a subtraction in front of g of x. So that means I'm going to have 5x cubed plus 1 minus x squared plus 4. Okay, I've distributed my negatives, so now I can combine like terms. 5x cubed minus x squared plus 5, and that's going to be our new subtracted function. All right, pretty straightforward, absolutely. Let's take a look at example number 2 with the other two operations. F times g of x, so that's f of x times g of x. Notice it's a closed circle. That means multiplication. This is going to have meaning in the next example. Okay, so we're going to take f of x, which was defined at the beginning, to be x squared plus x minus 6, and we're going to multiply it to g of x, which is x minus 2. All right, sorry about the sniffles, guys. We are going to distribute, so x squared times x gives us x cubed. X squared times negative 2 gives us negative 2x squared. Just going to use different colors so we can make sure we're keeping track. And then x times x gives us a positive x squared. X times negative 2 gives us negative 2x. We're taking every term in the first trinomial and multiplying it to every term in the binomial. So we get negative 6x, and then negative 6 minus 12 gives us, or minus 2, what gives us positive 12. Okay, so at this point, we've distributed everything in the first quantity to everything in the second. I'm going to combine like terms. I get x cubed, and then we've got minus x squared minus 8x plus 12. Whew, all right, nice work. So then for division, this means we've got f of x over g of x. F of x is x squared plus x minus 6. G of x is x minus 2. Now, sometimes the trinomials factor, sometimes they don't, as we've seen so many times before. But we need to really try and see if it factors. In this case, it does. And the reason I say we need to really try is because if we can simplify, we must. Okay, so it factors to x plus 3 times x minus 2. We can reduce the x minus 2's, and we are simply left with x plus 3. Sweet. All right, ladies and gentlemen, function operations. The big things to remember are that parentheses are helpful, especially when you are subtracting, because you might need to distribute that negative. Simplify as far as you can, and always cancel if possible. Okay, function operations. Now, I mentioned composition of functions. This is, notice, open circle, okay? It is not multiplication, it is an open circle. And what it means is g of f of x. So what we're gonna do is we're gonna take the function of f of x and substitute it in for all values of x in g. Now, if there is a numerical value, we must evaluate f of x first, and then use that output to evaluate as the input for g of x, okay? Verbiage, of course, a little confusing sometimes, but let's go ahead and practice. Now, example 3, okay, we need to find f of g of 3, g of f of 3, f of g of x, and g of f of x. I'm going to call this A, B, C, and D. Okay, f of x and g of x are given to us. So f of g of x also means, there's 3, sorry, f of g of 3. You can write them either direction, just like we did with the operations. So by order, I'm going to work inside out. I need to evaluate g of 3. The f is going to stay on the outside. G of x is x cubed. So I'm going to take this 3 and substitute it in for x. And I'm going to evaluate. So we now have f of 27. Okay. Now, f of 27, we know 27 is going to substitute in for x. F of x is x squared, so we get 27 squared. And I am not a human calculator, despite what many of you would hope. And you're probably disappointed. Totally okay. So if I square that, I get 729. Composition of functions. You take one, evaluate it for the given numerical value, and then substitute it into the next. So let's take a look at B. Now it's g of f of 3. I know that it's g of f of 3 because it's the open circle. So I'm going to evaluate f when x is 3. Okay, work from the inside out. So g is still on the outside. F of 3. F of x is x squared, so I have 3 squared. I'm going to evaluate that, and I get 9. So now I'm going to evaluate g of 9. So I'm going to substitute 9 in for x. I get 9 cubed. And 9 cubed, I believe, let me see. 9 times 9 is 81. I think it's 729, but I'm using my calculator to check. Yep. So they work out to be the exact same value. Now this won't always be the case, but it's nice that it worked out this way. Okay, C and D, there isn't anything to evaluate. So f of g of x, I'm still going to work from the inside out. Okay, I'm going to take g of x, and I'm going to substitute it in for every x value in f. Okay, g of x is x cubed. I'm going to substitute it in here. So that means, first substitute in g of x as x cubed. Then take the x cubed and substitute it in for every x value within f of x. Okay, x cubed squared, power raised to a power, we multiply, so this composes to x to the 6th. All right, for D, similar. We've got g of f of x. Okay, well that means I'm going to take f of x, which is x squared, as substitution, and I'm going to take x squared and substitute it into all values, or all areas of x in g of x, which is just 1, so we have x squared cubed. Again, power raised to a power, you get x to the 6th. Worked out to be the same, won't always be that way, but it was nice that it did. All right. Okay, when you have a relation, when you have a set of points, we're still going to find f of g of 3, okay? But it's a little bit easier. So f of g of 3, working from the inside out, I'm going to go to my g function, my relation, and see where is 3. Oh, it's right there. 3 corresponds to 1. 1 is its output. So now I'm going to evaluate f of 1. I'm going to go look at the f set, and I'm going to try to find 1 in, oh, hey, here it is, right here. And that corresponds to an output of -7. That's my answer. Okay? A little bit easier because you're not necessarily doing arithmetic. You're just matching values in a relation. G of f of 3. Okay, so now we're going to start with f, and I'm going to find 3 as an x value, and I'm going to match it with its output. In this case, it's 0. Remember, x is your input, y or f of x is always the output. So now I'm going to have to evaluate g of 0. I'm going to go to g, find 0 as the input, and match it to its output. This evaluates to 11. Sweet. All right. Now, if we're not asked to evaluate specific numerical values with relations, not too bad. We just go step by step. So the first one is f of g of x. We're creating a new relation. So the first input is 0. Okay, so I'm going to put 0. And 0 goes to 11. But do you see an 11 in f? No. So it's not possible to compose the functions without numerical values. We put D and E. It does not exist. Okay. What we did is we looked at the first input in G and tried to match its output in F. So if we were to try and work in the other direction, let's see if A can go from f of x to g of x. Okay. Start at F. The first input is 1. So that would be our first input. Okay. It corresponds to -7. So now I try to match -7 with G, but I don't see it, so it does not exist also. It's possible that they would exist. In this case, it didn't, okay, which is a bummer because we don't get to see it, but know that you would just continue in the manner that we did prior. All right, ladies and gents, last example. Here we go. For A, we would have f of g of 3. So I'm going to evaluate g of x when x is 3. So we have 3 squared minus 3 times 3 plus 7. All right, keep going. F of 9 minus 9 plus 7. So g of 3 evaluates to 7, which means now I'm going to evaluate f. Wait, why did I write 3? Oh, my Lanta. There we go. So now I'm going to evaluate f of x when x is 7. That means we would have 7 times 7 minus 5. 7 times 7 is 49 minus 5. It evaluates to 44. Always work from the inside out. Okay, so working in the other direction as the directions are asking us. G of f of 3. Okay, so I'm going to evaluate f of 3 first. We have 7 times 3 minus 5 leaves us with g of 21 minus 5, which leaves us with 16. So now we're going to evaluate g of x when x is 16. So we get 16 squared minus 3 times 16 plus 7. 16 squared gives us 256 minus 48 plus 7. Oh my gosh, I'm running out of room. Okay, I'm just going to do it in one fell swoop. Sorry, guys. So 256 minus 48 plus 7 is going to give us 215. Notice they're not the same. That's okay. The directions didn't say they had to be. Our purpose was just to compose. All right. For C, f of g of x. So we don't have any numerical value to evaluate. We're just going to take g of x and substitute it in. Okay, so now we're going to evaluate f of x for g of x, which means I'm going to take that trinomial and substitute it in for x. Oopsies, 3. Don't forget your numbers. And then I'm going to simplify. Okay, so I'm going to distribute my 7. So 7x squared minus 21x plus 49 minus 5. And combining like terms, because we are composing, we are creating a new function, so we need to get as simplified as possible. Boom, there it is. Nice work. All right, last but not least, D. We are going to take G and evaluate it for f of x. So G of 7x minus 5. And we have 2 different x's in G of x, so we're going to substitute it in twice. We get 7x minus 5 squared minus 3 times 7x minus 5. You substitute it in for all x's because you're evaluating just like you would with a numerical value, okay? So distribute, you get 49 x squared minus 70x plus 25. Distribute the negative 3 minus 21x plus 15 plus 7. Make sure I did that right. Looking okay. All right, combine like terms. So we get 49x squared. And then we have negative 70x minus 21x. We get minus 91x. 25 and 15 gives you 40 plus 7. All right, last step. Combine the 40 and the 7. So we get 49x squared minus 91x plus 47. Ta-da! And that's it. Nice job, guys. Okay, so if you're struggling a little bit with B, just because it is a relation, it's simple, you can always go back and it says in the explanation of the concept that the domain of G of F consists of the x values in the domain of F. Okay, so that means I'm going to take all x values in F and correspond them to f of x in the domain of G. Okay, what that means is just what we did. I took the first domain element, we wrote it here, and then we tried to find the output that matched. So the output for 1 was negative 7, which then went to the domain of G, and there wasn't any. Let's say that it had negative 7 comma 2, right? So then we would find it here, and it corresponded to 2. So then we would have had in our relation the point 1 comma 2. Yeah, it's connecting through the range, the output in F, to the input or domain of G. All right, y'all. Thanks so much. Let me know if you have questions.